cross-sectional studies, and then time series studies. All right. Now, you should be able to understand some concepts or what we call constructs in the research process. In research, when we talk about a variable, we are talking about something that is observable and that you can measure it directly. So that such an item is observable and directly measurable. So that because of this, we can turn that variable into some forms that can allow for decision making. Okay. So there are basically two main types of variables in quantitative analysis, two main types of variables. We have what we call dependent variable and then an independent variable. Now, when we say a variable is dependent, we can, thank you. We can look at it in the form of an equation where we say, for instance, that y is equal to the intercept a0 plus a1 times x. Now, in this relationship, y is what we call dependent variable. It is also sometimes called the outcome variable or the predicted variable. X is what we call the independent variable. It is also sometimes called the explanatory variable. In some cases, we call it the exogenous variable. Yet, in some other situations, we can call it the control variable. Now, we say y is the dependent variable if y relies on another variable or variables in order to have its values determined. Okay? So here we are saying that y depends on x. Okay? So we can say your income depends on what? Your skills. So x can be skills, and then y is your income. So we say that your income will depend on what? Your skills. Such that we can say that as your skills increases, your what? Income must what? Increase. But it doesn't also translate that as your income increases, your what? Your skills will increase. Okay? So we say that the left-hand side variable is called the dependent variable. And usually the right-hand side variable is the independent variable. Why? Because its values are not determined in this equation. It doesn't depend on any variable to get its values, okay? Like these skills. So unless, if you want it to become a dependent variable unless you create a model for it alone, such that x itself, which is your skill level, will now, for instance, be dependent on the intercept B naught, and then say your level of what? Education. In which case, you're saying that the more you educate yourself, the more you what? Develop your skills. In this case, X now also becomes what? A dependent variable in this model, but not in this. Okay. So if we want to determine X, we can't get its values here unless we develop a different model for it. Okay. So what you often see is this model where Y is, say, equal to A naught. A naught is the intercept. The intercept is the level of income if, say, your skill level is 0. If you have 0 skills, so this is equal to 0. What will be your level of income? Okay? That's what we call the intercept or the autonomous value. Okay? Then A1 is the coefficient of the independent variable. So A1 is a coefficient. So we call a coefficient. So A1, which is the coefficient of the independent variable, tells us the effect of the independent variable on the dependent variable. Okay. So this A1 tells us how X affects what? Y. Okay. So it can take values of various forms depending on the units of measurements of X and then Y. Okay. So for instance, A1, for instance, can be equal to 0.3, for instance. In which case, we can interpret it to mean that when X, because this is plus, increases by 1 unit, Y will increase by 0.3 units. So as I said, it tells us the effect of the independent variable on what? The dependent variable. Okay. So those basics have to be clear to you in terms of as you begin to learn how to set up models. This is the basic structure of a model. Okay. Very basic. We can have more than one independent variables. Take note. So we can have X1, X2, X3. Of course, skills is not the only determinant of income. Okay. So include all other determinants of what? Income. And you have a much more comprehensive model. But this is just an illustration that we are trying to provide, just for the sake of understanding following the discussion. Then you should be able to understand what we call a construct. Construct. Now, you have a question? You wanted to? The model. Okay. So I'm trying to illustrate two concepts, dependent variable and then an independent variable. Okay. If you have a simple model or a simple linear equation, so this is a simple linear equation. It's linear equation. You would usually express it, for instance, as, say, Y is equal to the intercept and then plus say A1 in when we talk about simple equations or lines, for instance. So let me show you something like this. This point is what we call A naught. That's the intercept. Okay, this is the regression, this is the line for this equation. The slope of that line is the A1. That's the A1. Okay, if you basic illustration of straight line. So where say this X, this Y axis. I'm talking about the axis. So we say that Y is dependent on X if Y relies on X in order to have its values determined. Okay. So that we are saying that it is changes in X that influence X to change. Changes in Y influence what? X to change. Then we say that Y is the dependent variable. No, changes in X, I'm saying that changes in Y is dependent on changes in X. Yes. Changes in Y is dependent on changes in what? X. Then we say that Y is the dependent variable and X is what? The independent variable. And extent to which X causes Y to change is what we call the what? The coefficient of X, which is this. Okay. Changes in the dependent variable that occur even if the independent variable does not change is depicted by the intercept. Okay, by the intercept. I don't know whether it's okay. Now let's go into a discussion of a construct. When we talk about a construct, we are talking about a concept that is composed of several variables. A concept that is composed of several variables. Okay? So for instance, suppose that I am discussing well-being. It appears they are used, so it's not sharp. Okay, this looks better. Okay, okay. Now, suppose that an example of a construct is, say, development. You cannot use one variable to measure development. So we say that development is what? A construct. Now, development can be measured by several variables. What are some of the variables you think we can use to measure development? You can use what? GDP. Can use what? Access to water. Electricity. Health. Education. Security. And so on. So in that case, we say that development is a construct, not just a simple variable. So in your work, you can come across a situation where you are dealing with a particular concept which you cannot measure using one variable. So we say that it's a construct. One construct that is often used in marketing is service quality. And even customer service. There are several dimensions of customer service. You can use one variable. Okay. So in that case, you have to spell out the various components of the construct. So we say that in order to come out with the construct, you may need to ask several questions or several statements. So for instance, if you want to find out about the development of the state of welfare of a family, you have to ask them questions about their income, access to water, electricity, health, their educational access, security, among others. So several questions. You can't use one question to do that. So that these individual variables will then be put together to give you a global view of what the construct. So we usually say that a construct is an abstract idea. Okay? It's latent or abstract in nature because you cannot just put your hand on it, because it's made up of what? Several components. So in your work, you will be dealing with several constructs. So I'm giving you an example here of a construct that could be, for instance, service quality as a construct. So if you want to measure service quality, for instance, you can ask the individual these questions, and the responses that are coming from these questions will then be used to construct or to put together your measure of what? Service quality. Because you know that you cannot measure it using what? One variable. So if, for instance, you ask the respondent to respond to the following questions in terms of whether they agree or disagree. Firms should have their customers' best interests at heart. So it means that one dimension of service quality that you are looking at is what? When firms have what? The customer's best interests in mind. So that's one dimension. Firms should be dependable. Dependability is a measure of service quality. Firms should be expected to give customers personal attention. So when they come to buy the good, you take your time, speak to them nicely, gently. Sometimes you even let them sit down, you serve them coffee first, and then the discussion can now start. Okay, so you give each customer attention. When firms promise to do something by a certain time, they should do so. So meeting deadlines and pledges or promises or delivering according to schedule. Firms should keep accurate records. So for somebody, service quality is when the firms will keep what? accurate records. Because you buy something and then later on you come and then you are arguing with them. They say it is this, and then you say it is that. So that can compromise service quality. So you then now put all these items together to now come out with your construct called what? Service quality. Service quality. Let's look at hypothesis test. If you are going to conduct, for instance, a quantitative study, it is very, very important for you to know how to set your hypothesis very clearly, clearly. And broadly speaking, we classify hypothesis into two. The null hypothesis and then the what? Alternative hypothesis. The null hypothesis and then the alternative hypothesis. What the null hypothesis does is that it makes some proposition that there is no association between the predictor and then the outcome variables in the population. In other words, to bring it back to where we were, it says that there is no significant relationship between the dependent variable and the what? Independent variable. So that's the terms that are used here. The predictor is the independent variable. And then the outcome variable is what? The what? Dependent variable. So you usually state the null hypothesis in a manner that there is no relationship. Okay? So you say that there is no relationship between, say, level of skill and what? Income. Because you have seen that, especially in this political environment, some people, you have more skills than them. But just by virtue of their political connections, they have more money than you, more income than you. So in that case, you can, if you are dealing with population that involve people of this nature, you can set your null hypothesis that there is no relationship between what? Skills and say income levels. That's your null hypothesis. Now, the null hypothesis, of course, let me exhaust that a bit before we come to the alternative hypothesis. So, for instance, once we state that there is no relationship, we can now subject that statement to a statistical test. So you are now going to do a test to see whether the A1, which we talked about, which is the coefficient of the independent variable, is statistically significant. That's the hypothesis testing proper using statistics. Okay. So that we usually recommend that when you are stating hypothesis, state it in the null form. In the null form. We've seen that over the years in business research, there is a deviation. Most people prefer to state the alternative hypothesis alone instead of combining them. First is to state the null hypothesis because that is what is testable. It's testable, subject to statistical test. So examples, the announcement of investment plan has no impact on share price. Usually in corporate finance, there is usually some assumption that once a firm announces its investment plan, then depending on how investors interpret the investment plan, it may either lead to an increase in what? the share price because of an increase in demand for the share, or it can lead to what? A decrease in the price due to the fact that investors are scared about your plan. They think that your plan doesn't give them hope. So the price will what? Come down. So if you are dealing with a topic of that nature, then you can state your null hypothesis that the announcement of investment plan has no impact upon share price. In this particular statement, which one is the dependent variable and which one is the independent variable? Yes. Correct. Correct. Yes. Because we are saying investment plan has no impact. We were expecting investment plan to determine what? Share price significantly. Okay? But the null hypothesis is that it has no impact. Then we can also say sales are not related to the amount spent on advertising. Which one is the dependent and which one is the independent? Yes. So here, okay. So it can be any of them. Here, we are just talking about relationship. So we talk about, when we talk about relationship, we talk about correlation. We are not seeking to find out which one has an impact. Look at the first one, talks about what impact on. The other one talks about relationship. The fact that two things are related does not mean that one of them depends on the other. It's different. Okay, two things can be correlated, but it does not mean that one of them is causing the other to what? To change. So in statistical analysis, you must always distinguish between causation and correlation. There are two different concepts, and most people confuse them. Causation means that one factor is causing what? The other to change. You can trace where the changes are coming from. Correlation means that they are moving what? In tandem, either in opposite direction or in the same what? Direction. But we cannot, such movements may not just be that one of them is causing the other to move. Okay. So for instance, we can experience high sales and then high advertising expenditure. But it may not really mean that what? Advertising expenditure is what is causing what? The sales to move up, or sales is the one causing what? Advertising expenditure to what? To move up. Okay. Yes. No. So this one, as I said, we are dealing with correlation. The one I illustrated was looking at causation. Okay. So where you are dealing with correlation, you have no dependent variable and you have no independent variable. It is when you are dealing with causation that you can have what? Dependent and what? Independent variable. So always and always ensure to distinguish between causation and correlation. The fact that two things are moving together, either in the same direction or in opposite direction, does not necessarily mean that one of them is causing what? The other to change. No. So if you observe both sales and then advertising spending going up, don't conclude that it's because of what? The advertising that what? The sales are going up. It can also just be the fact that you have what? Expanded the capacity of your production. So even if you did not advertise, you will still sell more. Or there are new markets that have been created for your products. So that can also drive your sales, even if you don't advertise. Okay, so get it clearly that you can have two things moving together, but none is causing the other to change. I said that the null hypothesis usually states the hypothesis in terms of no association. If you state the hypothesis in terms of the existence of an association, then that is what we call the alternative hypothesis. So you are just flipping the null hypothesis. The null hypothesis is that there is no association between what? The dependent and what? The independent variable. Whereas the alternative hypothesis says that there is a relationship between what? The dependent and then what? The independent variable. So there is an association between the predictor and then what? The outcome variable. Okay. So like we can reverse these ones, the examples I gave as our null hypothesis into, we can just convert them to alternative hypothesis by replacing no association with what? An association. So we said if there is an associate, we can say that the announcement of investment plan has an impact. Here, no impact. In the null, no impact. In the alternative, an impact exists. The same with the sales and advertisement. Sales are related to the amount spent on advertising. Sales are related. Statistically, we can't test the alternative hypothesis directly. Okay. Statistical tests usually test the existence of no what? Relationship or no impact. Okay. So what we often do is that we then admit the alternative hypothesis by exclusion. In other words, if the null hypothesis is rejected, then automatically we go in for what? The alternative hypothesis. That's why we mean by it is admitted by exclusion. If the null hypothesis is rejected, then automatically we embrace the what? The alternative hypothesis. These are examples of hypotheses. Okay, so let me read a few of them, and you tell me whether they are null or alternative hypotheses. Okay. Organizational commitment is related to supervision, co-workers, and satisfaction with the work environment. Is it null hypothesis or alternative hypothesis? It's what? Do you all agree? Some of you are not sure. Is what?
Alternative hypothesis.
Alternative. Okay.
Yeah, alternative hypothesis.
Okay. So almost all the ones stated here are alternative hypotheses. Okay. Almost all.
Prof.
Yeah.
Hello, Prof.
Yeah.
But most often when you are reading pure social science studies, they set this hypothesis as their null hypothesis. Unlike in economics, where we say that there exists no such relationship as the null hypothesis. When it comes to social science like business areas and the other, other social science related areas, they will state directly that they indeed exist that relationship. While in economics, we said that doesn't exist in the context of the null hypothesis.
So
I don't know why is it so.
That's what I'm saying. So it's all part of the training. Most social science researchers state rather the alternative hypothesis rather than what? Starting from the what? Null hypothesis. And we've all been victims to it. Because usually once you propose your topic, your aim is to find a relationship. So that urge to find relationship makes you to move straight to state the what? The alternative hypothesis instead of what? The null. Okay. So it's just the urge by social scientists to find relationship, sometimes at all costs. That makes them to always prefer to what? Formulate hypothesis in the form of the alternative hypothesis rather than what? The null. And usually, to cure this, we usually advise that you state both. So usually first you state the null hypothesis, which we usually depict as H naught. So for instance, in the example that one of the examples we provided here, share prices are positively impacted by what? Favorable performance announcements. So first you state the null hypothesis, and the null hypothesis will be what? How can we turn this to null hypothesis? Okay. Yeah, so you can turn it directly like that. Okay. So you just write H naught. Share prices are not what? Directly positively impacted by what? Then you now move to the what? Alternative hypothesis, which is depicted as HA, where the A is a subscript. Then you now state the alternative hypothesis. Share prices are positively impacted by favorable performance announcements. So first, share prices, H naught, that's a null hypothesis. Share prices are not positively impacted by favorable performance announcements against the alternative that share prices are positively what? Impacted by what? Favorable performance announcements. So that's your hypothesis stated. So null, and then what? Alternative. So that's the complete way to state hypothesis. Okay. In that way, nobody will challenge you. Now, when you want to develop hypothesis, you need to ask yourself two key questions. Number one, what group will be examined with the hypothesis? So what is the group under study? Okay. Number two, what variables are being tested? Okay. And you can see from the hypothesis we have presented that in each of them, at least two variables are tested. Okay, two variables are tested. But you can also have a single variable hypothesis where you are just testing one. Okay, one. So you can test it around the mean, median, or standard deviation, of course. Now, we can also classify hypotheses into two: directional hypothesis and non-directional hypothesis. Okay, directional hypothesis and non-directional hypothesis. Directional hypothesis will tell you the direction of what? The relationship, whether it's positive or what? Negative. Non-directional hypothesis will not indicate whether it's positive or negative. It opens itself up for any outcome, whether what? Positive or what? Negative. So for instance, if you take a directional hypothesis, which we also call one-tailed or one-sided test, okay? I don't want to take you deep into the statistics. But usually, if you have a normal distribution, these are the tails. So this is the data you have plotted. The extremes are the tails. So this is a 0 point. So you move towards this is positive. And this way is what? Negative, for instance. Then a one-sided hypothesis can say that the relationship is positive. So it means that you are testing only the left side. Or it can say that the relationship is negative. It means that you are testing only what? The what? The left side. So that's why we say one tail test. One tail what? So this is the tail of the distribution. The positive tail or what? The negative what? Tail. Okay. So we call it one-sided or say one-tail hypothesis. So, for instance, look at this example. The greater the stress experience on the job, the more likely an employee is to search for another job. Are we going to have the tail at the positive side or the negative side, the test? You're going to be positive, yes. Why? No. Look at greater increases as it increases. Okay, greater will mean as it increases. So as the stress levels what? Increase. Then we are saying that they will also what? Have the edge to what? Search for a job that can reduce their stress. So positive. In other words, you are saying that there's a positive relationship between what? Stress levels and then what? Employee likelihood of searching for jobs. Okay. If employees are given more safety training, then they will have fewer accidents. How? So as training increases, what will happen to it? See that? It's an inverse relationship. It's an inverse relationship. Because basically you are saying that employee safety training decreases accidents. Yes, that has a decreasing impact on what? Accidents. So you are looking for what? An inverse relationship or a negative relationship. An inverse relationship is a negative relationship. as one thing what increases, the other what decreases. Non-directional would usually say that the association exists, but it does not specify the direction. So for instance, you can say there's a relationship between what? Stress experience on the job and the likelihood of an employee and the likelihood that an employee will search for another job. So you are not saying that it will increase their job search or it will decrease their job search or propensities. You are just saying that the two are well related. Whether it is inverse relationship or positive relationship, you have not specified. So in that case, we say what? There is what? A non-directional hypothesis being tested. So you are testing for whether it will fall here or what? It will fall here. You are not restricting yourself to one side of what? The distribution, both the negative side and what? The positive side. So how do we turn this hypothesis? That's if employees are given more safety training, they will have fewer accidents. How do we turn it into a non-directional hypothesis? How do we turn it into a non-directional hypothesis? Hey, are you, yes, let me listen to. So you have taken a what? A direction. A direction. So why don't you remove the low? Remove the low, and then you'll be correct. Yes. Our savior. Okay, yes.
No training levels. Then in fact, accidents can be that was negative.
Yes. It's long. Yes. There's a direction. Yes.
So even safety training may have an impact on accidents.
Safety training is correlated with number of accidents. Simple. Safety training has an association with the number of accidents. Simple. Whether it's increasing it or it's decreasing it, it's another thing. So you test for both. Okay, test for both. Yes.
Number of accidents.
Yes, you can say that. No, you can't say that. You have reversed it. That's not. We are not talking about it in terms of that. You can rather say safety training has an effect on the number of accidents. But as to the effect, you have not said whether it's negative or what, positive. So that way you'll be correct. How many people do we have online? Into 5. Now, sometimes we encounter errors when we are testing hypotheses. And there are two main types of errors that you should advert your minds to when it comes to hypothesis testing. The first category is what we call type 1 error. And then the second category is type 2 error. So what is type 1 error? It is simply the situation where you conclude that there's an association when there actually is none. So you have misfired. Okay? You conclude that what? There is what? An association. Which means that you have rejected the null hypothesis when you shouldn't. When you shouldn't. So we call that type 1 error. It's also sometimes called false positive. False positive. You can, I'm sure you've ever come across false positive. Okay, it's positive. In other words, you have found that there's a relationship, but it's false. So we call it false what? Positive. Then we have type 2 error, which arises when we conclude that there is no association when there actually is one. In other words, you have refused to reject the null hypothesis. So in that sense, a relationship exists, but you have concluded that what? There is no relationship. So that becomes a false negative. Okay? So there's no relationship. And yet, a relationship exists. Okay? That's your conclusion is that there is no relationship. But in actual fact, there is. Okay? So two types of errors in statistics and in hypothesis testing. Yes, please. No. No. It's from the testing. It's from the statistical side. Okay? Those errors are committed from the statistical side. Okay? And we are not going to go through the intricacies of statistical hypothesis testing. But in terms of the statistics, remember I talked about the coefficient of what? The independent variable. If you are going to test a null hypothesis around it, the null hypothesis will simply say that that coefficient is equal to 0. Okay, so that coefficient, which I illustrated earlier, you are saying that A1, which is the coefficient of X, is equal to 0. That's how you test. That's the statement of the null hypothesis. Okay, sometimes mathematicians make things easy. So this is a whole sentence. You will say that skill level has no impact on income. Okay, you can simply write it this way, and you are free. As against the alternative hypothesis that A1, we can state it either, so because this is equal to, this is what? In non-directional one. So we say that it's not equal to 0. Then that, not equal to 0, which means that it can be what? More than 0 or what? Less than 0. So this becomes what? A non-directional hypothesis. We can state this in a directional form such that we say that H0 is such that A1 is equal to 0. The null hypothesis is always saying no relationship, so it's equal to 0. As against the alternative, which can say that A1 is greater than 0. That's one form. You can also state it differently, that A1 is what? Less than 0. You can state it yet in another form, greater than or equal to, less than or equal to. Okay. So the statistics will then measure this one and test it to see whether it is significantly equal to 0. It is significantly different from 0. Okay. It is significantly different from 0. So usually at the MSc and then the MBA, we don't do the statistics. Okay. But with MPhil and PhD, we do the statistics. So I would have shown you results and then be able to also teach you how to estimate and then what? Test hypothesis. But here we are just doing the research methods. So the approach, not taking you through the statistics. So I'm not going to ask you to test any hypothesis for now. Okay. Later on, you can test more of that. Okay. So these are examples that you can look at. Okay. Not easy. The time is flying. What's rep? How do you hold the time constant? See, you see that. So you just have to follow the time. Okay. Conceptual models. But this one, I can ask you to develop a conceptual model. Okay, so I think last year, one of the 10 papers, they developed a proposal, and at the end, they developed conceptual model. Okay, so we are going to go through what a conceptual model looks like and how to construct it. So it's not just a disclaimer, it's not a mathematical model. Okay, so that your minds will be at ease. It's not a mathematical model. Okay. 5 basic elements of a conceptual model. We have 1, theoretical constructs. 2, measured variables. 3, unidirectional relationships. And these are usually shown by single-headed arrows. So an arrow where the head is one on only one of the ends. Okay. Then we have bidirectional relationships. These are depicted by double-headed arrows. So an arrow where both ends are heads. So if you see double-headed arrow connecting two constructs or variables, then we are dealing with bidirectional relationship. In other words, both constructs are related to each other. Okay. Then lastly, there are error terms. There are error terms, which are basically describing what we call random events. Random events, okay? Or sometimes issues that are not captured by the model. They are captured by the error term. So in the relationship that I described here as y being explained by x, I can then add, say, the error e to make this model complete, where this error term will capture all other factors that explain y, which are not captured by what? X. Because x is not only, so the measurement error among other errors are usually captured by what? The E, the error term. So if you have a conceptual model, you can look at it from its components, based on its component. One, we have the inner model. The inner model. And usually, the inner model is used to capture theoretical constructs. Like we illustrated here, development. It's a theoretical construct. Okay? Or sometimes we call them the latent variables. So you use that inner model to capture those ones. What it does is that usually it will show you the relationship among theoretical constructs, either using double-headed arrows or single-headed arrows. So we usually display them in the form of oval. Oval. So we usually depict them this way, or sometimes circles. So if you see a variable, usually, so this is a general recommendation, because some people can decide to use different shapes to illustrate that. Once they define them, then that's okay. But usually, in this model, we usually use ovals to represent what? The theoretical constructs. And we can then show the relationship using what? Single-headed arrows or what? Double-headed arrows. So, and we say that the double-headed arrows indicate bidirectional relationship. And for that matter, they represent correlations or covariances, how the two variables are moving together, or they vary differently. That's what we call the correlations or the covariances. Whereas the single-headed arrows are usually interpreted as causation. Remember, I distinguish between what? Correlation and what? Causation. Single-headed arrows, causation. Double-headed arrows, what? Correlation or covariance. Then we have the outer model. The outer model will show us the relationship between the theoretical constructs and then the indicator variables. So the indicator variables are usually represented in what? Rectangles. So in the outer model, you begin to see rectangles. The inner model, ovals. Outer model, what? Rectangles. Again, relationship can be depicted either unidirectionally or one directional. And we usually refer to it as the measurement model. The inner model is also called the structural model. The outer model is called the measurement model. Okay, so understand that. If I give you the pictorial depiction, you'll get it clearly. But I want you to get the meanings clearly first before we get into displaying the sample. Usually, you can categorize your conceptual illustrations either in the form of a conceptual model or a theoretical model. Okay? Sometimes they are used interchangeably, but there is some kind of difference. With the conceptual model, it's just a general diagram that depicts how variables and constructs are related. Okay, so it may not be necessarily underpinned by a theory. Okay, so you are just putting the constructs together without necessarily explaining the relationships using theory. When you now impose a theoretical illustration on the conceptual model, then it becomes a theoretical model. So a conceptual model that is liaised with theory is what we call theoretical model, or some call it the theoretical framework. Conceptual framework is there, and then we have what? A theoretical framework. Okay. Sometimes you are dealing with a relationship where there is no strong theory. So in one of my papers, at the time that I was writing it, there were no strong theories. So I had to develop a conceptual model and then try to explain it based on my understanding of the area that was under the study. So let's look at some examples, and I'll show you the full model. So let's see a simple conceptual model. You want to look at wireless minutes usage. And you think that this can be explained by age, income, or what? Gender. So that this one is more or less like a construct. So if we want to follow the tenets, we can depict this as an oval. Okay, remember we said that, and it's because this is a simplified model. That's why we just made that one also a what? Rectangle, but we can make it an oval. Okay, if I show you a full model, you understand what I'm talking about. The same thing, we can also have another simplified conceptual model where we are looking at how advertising budget impacts sales. So you see that advertising budget, what? impacting what? Sales. So you are looking at sales and then a variable that what? Predicts that. So is it a unidirectional relationship or bidirectional? This one is
Unidirectional. Unidirectional.
Why?
Because advertising budgets is being mapped onto sales, and the relationship is uni.
Yes. So we are using what? A single-headed arrow.
Yes, Dr.
The same here in terms of the second illustration. Sales being impacted by what? 3 variables. Okay. Advertising budget, number of salespersons, and then website traffic. All mapped onto what? Sales. Okay. So look at this model that has about 4 different constructs. Remember, so this is an example of what? The inner model. All these are constructs represented by what? Overs. Remember, we mentioned that the constructs are represented by what? Overs, or the inner model is represented by what? Over. Here, productivity is a construct. It has its own determinant, but for simplicity, we have not included those determinants here. The same as technology implementation. That one, you can even see the constructs, shared values, technology acceptance climate, and then productivity as set to be among the variables whose relationship will be important in the technology implementation process. But we can look at this in this regard. We are saying that technology acceptance climate positively affects what? So look at the plus and the direction of the arrow. So we're saying that the relationship, we said that single-headed arrows also measure what? Causality. Remember, okay, they measure causality or causation. Okay, shared values impact technology implementation what? Positively. And when technology is implemented, it positively affects what? Productivity. Okay. So that's how we explain the relationship. So this is a more expanded version of it, a full view of it. Taking out the productivity part. So we are just to be able to contain the elements in the model. Now, technology implementation, technology acceptance climate, and then shared values form what we call the inner model. Okay, the inner model made up of what? Theoretical constructs or latent variables. And we said that they can be depicted by single-headed arrows or what? Double-headed arrows, okay, as we have here. So that's what we call the inner model. Then we have the outer model. We said that the outer model is represented by what? The rectangles. Okay, so these are the rectangles. X1, X2, up to X's, and then what? Y1, and then what? Y2. Then we said the last part is to include what? Errors, the error terms. They are in the circles. Usually, each of the variables has its associated error. Okay, so you have from E1 to E6, and even here up to E9. Okay, up to E9. So this is a depiction of a conceptual model that has 8 measured variables. So first, it means that we are saying that technology acceptance climate, which is a construct, is measured by 3 other variables. And then shared values as well is measured by what? 3 variables. So that is what makes it a construct or a latent variable. It is an abstract concept, okay, which we need to ask several questions to be able to what? Measure and capture its magnitude. Okay. So when you have your research topic, you should be able to draw a diagram of this nature. So that becomes your conceptual model. So any research topic you pick, you have constructs. So try to depict the diagram like this and tell the story. That way, it's easy to communicate with your supervisor that this is the picture of my model. I am saying that technology implementation as a construct is explained by 1, 2, 3, 4 items. And I know that the impact of that I'm dealing with is such that technology acceptance climate affects what? Implementation. And then shared values within the organization also affect what? Implementation. And there's also a relationship between what? Technology acceptance climate and shared values. And shared values itself is measured by what? 3 variables. The same as what? Technology acceptance. So the relationships are clear. And sometimes, not just sometimes, but these arrows and their movements represent hypotheses. You can tease out hypotheses from them. So usually, if you read some of the articles on this arrow, they may say H1, which means hypothesis 1. They'll start numbering them. H1, H2, then H3, H4, H5, H6, H7, H8, H9. So they will have up to 9 hypotheses being tested. Such models are usually common when you are using an approach called structural equations modeling. It's a popular technique that is used in management research, or partial least squares modeling. These are popular techniques, which in one way or the other, you may have to learn. You may have to learn them. Okay, we don't need this again. Now, in terms of research method or methodology, we usually discuss 2 approaches, qualitative and what? Quantitative. Sometimes there is a need to combine them. Okay, so we have mixed method. This table tries to compare and contrast the 2 based on purpose and properties. In terms of purpose, the purpose of quantitative data, the quantitative approach is to collect quantitative data or numerical data. Whereas that for the qualitative is to collect qualitative data. And the quantitative approach is used for mainly hypothesis testing, whereas you use the qualitative approach for discovery purposes. The quantitative approach will also provide summary statistics about the characteristics of your population or sample, whereas the qualitative approach will provide in-depth information on some few characteristics because of the thick nature of the data that the qualitative people collect. The data collected from qualitative studies is usually thicker than the one for the quantitative. For that one, sometimes you may have to use a recorder and record the information. Every word will be recorded. For quantitative, I don't need every word. Give me the figures. Yes. In terms of properties, the quantitative approach uses a more structured data collection approach. So it will often involve questions that you have to answer directly, either by selecting among options provided, or you just state the figure or indicate yes or what, no. They are not so much interested in the explanation. The data will speak for itself. Okay? The qualitative people will want you to explain. Okay, because they feel that there are reasonings and truths behind the numbers. Okay, truths that the numbers cannot reveal, cannot be quantified. So that's where the qualitative approach will come about. So they use an unstructured approach. So they will usually ask questions, explain why, and all that, or describe. The quantitative people are careful to ensure that their sample is representative. In other words, the sample should just behave like the population. Otherwise, we cannot make inferences from the sample and then generalize it upon the population. For qualitative, they are not so much interested in representativeness. All they want is for the sample to be authentic. Are you the right person that I should interview? Yes. That's all. No need for what? Representativeness. Then, the quantitative guys are interested in achieving reliability and validity. Okay? Whereas the qualitative people are simply interested in trustworthiness. Is it something we can trust? That's all. So they will not be concerned so much about Kroback alpha and all those measures that you use to determine reliability. Okay? They are interested in trustworthiness. The quantitative usually involve short interviews. We say that you can fill this questionnaire in 5 minutes, in 20 minutes. But for the qualitative people, no. You have to give them a chair. Then they sit down and then pull out their recorder. They have, sometimes there's a different person taking the notes from the interviewer. They are not in a hurry. They sit down with you, but you see the quantitative people, they are always in a hurry. So they will even be happy if you can let them leave the questionnaire behind so that they will come for it later. They have no time to be greeting, exchanging pleasantries, and then be asking for your wife, your children. No time for that. Let's go straight to the work and get the measurement, that's all. Usually, the quantitative people deal with large samples because of the quest to generalize. So they often would have samples over 50. The qualitative people, small samples. For qualitative research, you can even interview one person, that's all. You are done. Okay. You don't, they don't focus on, it may not be generalizable across what? The population. But it is generalizable to theory. I understand that. That's their concern, whether you can generalize it to theory, not necessarily to population. That's the qualitative. But the quantitative guys will want it to be generalizable even to the level of what? The population. You see? What? Which one?
Among the sample, because we deal with one person,
Yeah.
he comes out with his findings or whatever, and use another population who gives their views. You can't use one person to say like.
So there are circumstances where the one person is enough. Okay. So for instance, if I want to know about the views of the president about his own administration, that's all. Do I need anybody else? He's enough. Just one person. You understand that? He is the one that can give you that information. So I will sit down with him and then interview and let him know that I'm recording it. If he lies, that's it. You can subject it to whatever analysis to determine whether he's lying or what. He's telling the truth. Yes. How is it standing out?
Richer, the more acceptable.
No, it will not always be richer. Each has its own strengths and what? Weaknesses. So we can't say it will always be richer. It depends on what you are looking for. Okay? For somebody, it's the numbers that are the richest. When you talk of richer, it's the numbers. For others, it's the explanations.
You know, I asked because earlier on when we were working us through the research of the material, you know, and you made the difference that the media publications on just depend on that. Now they are even more beyond that. And you see it laid out in there for that. To show you evidence and the case. What the qualitative and what is coming out of whatever story they are putting and giving you evidence to make their story.
That's what I'm saying. Whether qualitative or quantitative, you can produce evidence. While one is producing evidence made up of stories, the other is producing evidence made up of figures.
Exactly.
Yeah, so that's what I'm saying. So it's your preference. It's your preference. But we cannot say that one is richer than what? The other. Every body will have their preference. sometimes those preferences are driven by also your giftings. Because if you are not strong in modeling, you will naturally go into qualitative. But if you are strong in modeling, you don't want to waste your time. You think that it's too demanding in terms of your time. Why would I go about interviewing people and be asking them why, when I can just collect the numbers and and come to the same conclusion? Okay. All right. All right, so let's look at research design before we close. There are three main research designs, basic. So I'm talking about basic research designs. Explanatory, descriptive, and causal. We have more than these, but at the basic level, research design can be classified into three. And that's where we want to focus at the moment. Exploratory design. In exploratory research design, the objective is to discover. Okay, so to explore is to what? Discover. Okay, so to discover something, and this is usually used in subject areas where you are looking for new knowledge, new understandings, new insights, and in studies where the theory is not strong or theory does not exist, you have to discover. Then descriptive design is used when the researcher wants to understand the characteristics of the population or sample. So you just want to understand the characteristics. So you describe. You describe the age, describe the educational status, you can describe the employment level. So the aim is just to look at the relationships. No, so I'm yet to come to causality. So the aim is to describe what exists in the descriptive phase. The third one is the causal design. In the causal design, the researcher is interested in cause-effect relationships. Cause-effect relationships. So that you are looking at how one variable causes another change, or both variables cause each other to change. Okay. So you try to ensure that you establish the nature of the relationship. So you would find that at this third level of design, you will be interested in some form of what? Hypothesis testing. It will be difficult to competently carry out a research that has a causal design without what? Testing hypothesis. In the exploratory design, you may not need to test any hypothesis. In the descriptive, you may or may not test any hypothesis. But in the causal design, you of necessity must what? Test hypothesis. Because you are making a bold claim of the existence of a relationship or the non-existence of it. And for that matter, you must establish what exactly is the situation, whether the relationship exists or it does not what exist.
Hello. Hello, Prof.
Yes.
Prof, so where do cross-sectional design, case study, sequential, explanatory, or exploratory design, where do they fall under this?
So, as I indicated, and of course, if there's time, we'll come to that. You can classify research designs in several forms. And the most basic classification is to classify that according to exploratory, descriptive, and what? Causal. You can also classify research design based on the approaches. So remember we said that you can classify research based on what? The time dimension. If you are using time dimension to classify research design, then you can classify research design as what? Cross-sectional, longitudinal, or what? Time series. Okay. You can also classify research design in terms of whether you are doing a case study. So here we are using the approaches. You are using an ethnography or some other approach. Okay. So several ways of conducting research design, but at the most basic level, you can use the approach that I'm talking about. Okay, so some classify research design using the strategies, and these are some of them that I'm flipping across. So you can have an archival one, can have a survey approach, experiment approach. You can have case study. You can have ethnography. Okay, in that order. Okay. So at the most basic level, as I indicated, three main what? Designs. Exploratory, descriptive, and what? Causal. So you will find that sometimes these also align with the philosophies. Remember, we said methodology is linked with what? The ontology linked with what? Epistemology, and so on and so forth. So which of the philosophical schools, either positivist, constructivist, or pragmatist, or realist, which one of them will use a causal design?
A positivist approach.
Yes, the positivists are more inclined to use what? A causal approach, because in terms of the design, because they are saying that one variable influences or causes the other to what? To change. So to be able to do that, you must first assume that those two variables are measurable. And measurability will mean that they are objective constructs. So that will take you back to your what? Your ontology. Then your what? Epistemology, in that order. And also the axiology. Okay? then they will believe that it's value free. The causal relationship is what? Value free. So you should be able to link them like that, okay, across the research process. So the descriptive design, they will usually use measures of central tendency. They will use count data, frequency counts. They will use the mode, for instance, and maybe measures of dispersion, such as the variance and then the standard deviation. So because they are just describing characteristics. Causal designs are usually more challenging in terms of what you must do to be able to establish causation. Because it's not a mean endeavor for you to stake a claim that one thing causes another one to change. Okay, and I often give this as an example that suppose that you have come and then you've seen a man sitting under a tree and the man is smoking cigarette. And then you get to know that the man has cancer. Okay? So the question is it the cancer that caused the man to smoke so that he will manage the stress that comes with knowing that he has cancer? Or it is the smoking that caused the cancer? How do we establish it? Is it the smoking that caused the cancer, or is the cancer that caused what? The smoking. So that's the issue of causation, causal inference. So this quantitative or causal approach must take due care to follow these four conditions to be able to establish this question that I just posed. First, he must establish the time sequence. Was he smoking before he had the cancer, or the cancer came afterward? The smoking started afterward, the cancer. Establish time sequence clearly. Then establish covariance. That is to say that a change in one variable is directly associated with a change in the other. Okay? Then establish what we call non-spurious association. In other words, take due care to ensure that you have accounted for all the factors that can cause cancer, apart from smoking. Otherwise, if you just look at the relationship between smoking and cancer, you may end up saying that smoking leads to cancer. Meanwhile, the actual problem is that the cancerous genes, the cancerous are in the genes. It's just due to gene defects, not because of smoking. So you have to control for what? The gene effect, and then the other possible causes of what? Cancer. Before you can then beat your chest and say that the cancer that I'm seeing in this man is due to what? Smoking. So that's what we mean by what? Non-spurious correlation. Then you have to find theoretical support. And in other words, there has to be a logical explanation that explains their causation. So for you to say you are doing a causal design is not a small journey that you want to embark on. And all these and many more conditions have to be satisfied for you to establish that. Any question before we close? So, for instance, this is an example of a descriptive statistics that is produced from using a descriptive design. So you are just giving background information. Me, so women, men, then the overall mean. Here is about ratings of the background music and service quality. Okay? A background music, usually adverts liaise with some background music. Okay? Or sometimes you go to shop, there's a music playing in the background. So you want to see the relationship between the background music and the service quality ratings by customers who are men and those that are women. So, and the ratings are given this numbering. A rating of 1 means unfavorable. And then 7 means very favorable. And you can see that from here, almost all of them have rated the mean to be very, very favorable or somewhat favorable, because they all have exceeded the half point of 3.7. So these are the means of the background music, and then the mean of what? Service quality. Okay. So you are just describing. You are not saying that the background music is what is causing service quality. No, you are just presenting the descriptions. Okay, no, you don't want a problem being accused of producing non-spurious or spurious results. Okay, if we say your results are spurious, it means that your results don't make sense. Okay, they don't make sense. You can deduce that there's a relationship. That's the right way to put it. A relationship. Don't commit yourself and talk about influence. So generally, we would advise that if you are doing a work and you are dealing with something like this, you can't stop here. You have to move ahead to test hypothesis. Because even our undergraduate students, we don't let them stop here. Because this is too simple. Okay. It doesn't give much in terms of the implications. So are you able to test whether the mean values between the males and the female is statistically significant? See that the males is 4.6. The female is what? 5. Can we say that the 4.6 and the 5, they are the same? Statistically, remember, with your eyes, you can say they are different. But statistically speaking, they can be the same. So you have to test hypothesis, whether the difference is statistically different from 0, or it is just due to chance. Okay, so it could be that the difference in the rating by men and women is due to chance. If it's due to chance, we don't need to worry ourselves because we can't control chance. But if it is statistically significant, which means that it is statistically different from 0, then it means that we have to take notice and implement policies based on it. So at the moment, you cannot give an advice based on this. So you have not established that one of them is causing the other to change. So what recommendation are you providing? Which policymakers should use to improve upon their processes? So once you start collecting data, which is quantitative in nature, I would say that make up your mind to test hypothesis. Otherwise, your research will end up being shallow. Okay. Course rep, any issue? You are good. Yes.
Times before election, then maybe like 15 days of school by somebody. Are they very
They are quantitative. Mostly they are mixed. They are mixed methods. They try to provide explanations, give reasons. So they are usually mixed methods. Yes. Man of God, any question? No, really. Not really. So we can close. No, I don't want you to get the slides and you don't come for lectures. That's why I don't give it out. You will not come. Today, the attendance is good. I'm happy about the attendance. Because I was worried when I saw the numbers in terms of the grouping is more than what I usually see in class. And then what he usually reports in terms of those who join online. How many today? Earlier 5, up to 7. So it means that we are getting the true numbers now that the assignment.
You are only 8 now.
What is that?